Hello Math 130 students, we are going to pick up on page 22, section 8.6, using the properties of logarithms. So again, we're going to revisit some of our properties that we've already been introduced to, which was the product rule, the quotient rule, the power rule, and the change of base. So for example number 1, it's specifically asking us to expand the logarithm. So remember, to expand is to make bigger. So we are going to expand log base 4 of this fraction. So because I have division, then I should be thinking about the quotient rule. So since I have the quotient rule to apply, well, that tells me I'm going to do a subtraction. So I have log base 4 minus log base 4. So what we're going to plug in matters the way that it's represented. So here I have my numerator. So our numerator is going to be written first. So that's the square root of x. Next we have the denominator. So that's a 16y fourth. So that's going to be written secondly on the right hand side. Now we're going to think about what the square root means. Well, this really means that this is log base 4, and that square root of x, it's x to the 1/2 minus log base 4. And here I have a product rule. I have two things that are being multiplied together. I have the 16, so that's definitely true. But now I also have the y to the 4th as being multiplied. So here not only am I going to use the quotient rule, but because this is multiplication, that indicates to me that we're also going to be using the product rule. So since that's the case, since I have this power here, we're also going to be using the power rule. So that power is going to come out in front. So I'm going to have a 1/2 that's being multiplied by log base 4, and I still have x in here, minus, and here, since I have the product rule, I'm going to go ahead and do this in brackets. I have log base 4 plus log base 4. So here I have the 16, and over here I'm going to have y to the 4th power. And don't forget that 4 is going to come out in front as the power rule. So this is telling me that I'm really going to have 1/2 log base 4 of x minus log base 4 of 16 plus 4 log base 4 of y. And because this is, say, a subtraction, you can think of it as a -1 that's going to get distributed. So now I have a 1/2 log base 4 of x minus log base 4 of 16 minus 4 log 4 of y. And here we can still simplify. We can simplify this log base 4 of 16. Well, over to the side, if I have log base 4 of 16, if I were to rewrite it as an exponential, that's 4 to some power is equal to 16. Well, 4 squared is equal to 16. So I know that this entire thing is going to equal to a 2. So now, really, my final answer is 1/2 log base 4 of x minus, And remember, we did this work over here. Log base 4 of 16 is really equal to 2 minus 4 log base 4 of y. And so that ends up becoming my final answer. Okay, I'm gonna go on to number 2. I'm gonna pause so I can give myself more room. So for number 2, it looks like we have the quotient rule because we have division. So I'm going to separate this out as log base 5 minus log base 5. And so what I'm going to be putting inside the first pair of parentheses is going to be my numerator. So that's a 4ab to the 3c to the 4th power. And what's going to go in the second pair of parentheses is going to be my denominator, which is my d squared. So here for the first one, I can see that all of these are being multiplied. So that means I'm going to have to split it into addition. So I'm going to have log base 5 plus log base 5 plus log base 5. Let me see if I have enough. I have the 4 that's being multiplied, the a that's being multiplied, b to the 3 is being multiplied, and it looks like I need one more. So then log base 5 of my c to the 4th power. And I have my log base 5. And here what I can see is that my exponent is 2. So that tells me to use the product rule. So that's going to go out in front. So I really have minus 2 times my log base 5 of d. And I also have the exponent rule here and here. So now I'm going to have log base 5 of 4 plus log base 5 of a plus log base 5, oops, and I forgot to put that 3 out in front. So 3 log 5 of b plus, and that 4 comes out in front, log base 5 of c minus 2 log base 5 of d. So all of that becomes my final answer. Now let's look at number 3. So number 3, it looks like it's all being multiplied, so we're going to split it up into our product rule. So we have this equal to log base 2 plus log base 2 plus log base 2. I have 3 things going on here. I have my 3, I have my x to the 5th, and I also have my y to the 3. And because of our power or exponential rule, we can bring that out in front. So this really becomes log base 2 of 3 plus 5 log base 2 of x plus 3 log base 2 of y. And so that ends up becoming my final answer. For number 4, that's going to be very similar, where we know that these two things are being multiplied together since it has multiplication. So I need to go into my product rule. So log base 3 plus my log base 3. So I'm going to have a square root 2, and I'm also going to have an x squared. So remember that if I have square root of 2, that's really 2 to the 1/2 power. So now I can use my exponent rule or my power rule that I'm going to bring out in front. So that 2 times log base 3 of, oops, and that wasn't 2, that was a 1/2, thank you. 2 plus, and here my exponent is a 2, log base 3 of x. And so that's going to be my final answer, expanded out as possible. Now for number 5, it says to write log base 4 of 10 as a quotient of natural logarithms. So this one is kind of using my change of base. So what I like to remember is that the b base goes to the bottom. So base goes to the bottom. That's how I always remember it. B for base goes to B for bottom. So here I'm going to have natural log of 4. So that means that 10 is going to go in my numerator. So I have this as the natural log of 10 over the natural log of 4. And it says to write it as the quotient. So it says do not simplify, it just says to write it. So there it is. And then here for number 6, it specifically says use the change of base formula to approximate log base 6 of 51. So then you know, because of the change of base that we used earlier, we are going to rewrite this. So I'm going to have log and log. And what we want to do for the log, it defaults to a base 10 on your calculator, so it's easier to calculate when you want a decimal approximation if you have log base 10. So remember what I said, b base goes to the bottom. So I'm going to have a 6 in the bottom, so that tells me my 51 goes in the numerator. So now, when I bring up my calculator, I'm going to have the fraction, and you have this on your calculator as well. You have log, actually, the log button's right here. So log of 51 over the log of 6. And so that gives me my answer. So I've just copied down the decimal that I got on my calculator, and it specifically says to round to 3 decimal places. So this is the 3rd decimal place. So for this digit, it tells us to leave it alone. So rounded to the 3 decimal places is 2.194 as your final answer. And that is the end of section 8.6. If you guys have any questions, please feel free to email me, the Math Success Center, or our tutor. Thank you.